Hi students, welcome to our physics channel Physics Star. Today I am going to explain about rolling on an inclined plane. Okay? If you have any doubts regarding rolling on horizontal plane and how to find the acceleration, how to find the velocity, how to apply law of conservation of momentum in case of law of conservation of angular momentum in case of rolling object on horizontal surface, how to find the instantaneous axis of rotation, you just watch my, if you want these videos, if you can watch my previous lectures, previous videos. There are some problems which I solved there, so you can understand. Right, now let us discuss about rolling on inclined plane. So in this, suppose if an object is there which is rolling, okay, from the top to bottom of an inclined plane, assume that angle of inclination is theta. Now my question is that why is it in rotatory motion? Why is it rotating? First of all, is it because of mg, means weight, or because of frictional force? If it is a smooth plane, will it rotate? If that inclined plane is very smooth, will it rotate? Means will it roll or it just translate? Here the answers let us discuss now. Okay. Now here observe the diagram here. An object is rolling down the inclined plane. How many forces are acting on it? Two forces or three forces? What is that? Mg, and these two are two components. Let us leave it. First mg force is there, weight, and the other one is normal force, and the other one is frictional force. If it is a smooth plane, then friction is equal to 0. If it is a rough plane, then definitely friction must be existing here. Then is mg exerting? My question is that does weight provides or produces torque on the object? The answer is no. Why? Because weight is passing through axis of rotation, that's why it does not produce any torque on it. Okay, then which one produces the torque on it, which one rotates the object? Then answer is that only frictional force. Only frictional force produces torque on it. Okay, only frictional force produces torque on it. Now while it is sliding down, okay, as we have discussed now, it produces the frictional force produces the torque. What is the direction of friction? Direction of friction is upward. Okay, it is always in the upward direction. Why? Just once read the horizontal surface, so direction of friction on horizontal surface, you will understand why the friction is in upward direction. Okay, now let us discuss when the object is rolling down, it will have two different accelerations. What are they? One is acceleration of center of mass, means it is in translatory motion. Because of translatory motion, it gains certain acceleration, which is what we call acceleration of center of mass. How to find that acceleration of center of mass? Quite simple. Net force equal to mass into acceleration. Now let us discuss what is the net force. Net force is nothing but mg sine theta minus F is equal to mass into acceleration. What is this acceleration? Acceleration of center of mass. Okay, consider this equation as 1 now. Now, which force is producing the torque now? For only friction. Okay, so torque produced due to friction. torque due to the frictional force. How to find the torque due to frictional force? F into what is its perpendicular distance? Observe here, perpendicular distance is r only. Am I right or not? From the center, if we consider the perpendicular distance is r only, right? So F into r is equal to I into alpha because of Newton's second law. Torque is tau is equal to I alpha. Okay, so therefore F into r is equal to, what is I value here? Simply whether which object we don't know, which object is rolling we don't know. That's why we will write that in terms of radius of gyration, that is mk square into alpha value. Alpha value is simply written as a by r. Why? Because I am assuming that the object is in pure rolling condition. That's the reason why alpha is equal to a by r. Okay, so let us send this r to the right side so that it will become f is equal to mk square into a by r square. Yes or no? Now what am I doing? I am just applying f value in equation 1. So what do I get now? That is mg sin theta minus, let us write a little bit down, mg sin theta minus, instead of friction I am writing mk square a by r square is equal to m into a. Okay, now send this minus mk square a by r square to the right side. It will become, I am just taking ma as common so that it will become 1 plus. If this minus goes to the right side, it will become plus. Hence m a into 1 plus k square by r square, which is equal to mg sin theta. Here mass gets cancelled. Therefore, I need to find out the acceleration. Therefore, acceleration of the object, acceleration of the rolling object. What is that formula for acceleration now? A is equal to g sin theta by 1 plus k square by r square. Okay, here let us write this k square by r square as a constant. If we take different materials, different objects like solid sphere, hollow sphere, ring, disc, like that, k square by r square is different for different object. Am I right or not? If it is a ring, then k square by r square value is how much? 1. Because k value is what? Radius of gyration. If the ring is rotating around its own axis, then what is its k value? It is r square only. K is equal to r only. Because mr square, no? Moment of inertia. And if it is a disk, it is mr square by 2. It means that k is equal to r by root 2. If it is a hollow sphere, it will be k is equal to, or k square is equal to 2 by 3 r square. Am I right or not? If it is a solid sphere, it is 2 by 5 r square. Like that, for every value, for every object, it will have a different value. K square by r square, you will get a different constant. Whether it is 1 or 1 by root 2 or it may be 2 by root 2 by 3 or root of 2 by 5 or whatever it may be. Okay, na? K square by r square, not root, you don't get root. So you will get different values, right? That constant I am writing it as beta. Beta is equal to, let us assume that beta is equal to k square by r square. Therefore, acceleration is now written as g sin theta divided by 1 plus beta. G sin theta divided by 1 plus beta. Now, remember this formula. Now let us find the force acting on it. Okay. So in order to find the force acting on it, now what am I doing? I am just taking a value in equation 2. I am just substituting the a value in equation 2 here in equation 2. Therefore, F is equal to m k square by r square into a value is what? G sine theta divided by 1 plus beta value k square by r square. Or else you will, no problem, let us write like this first and later we will simplify. M into beta, because k square by r square is here also. So m beta into g sine theta divided by 1 plus beta. Am I right or not? 1 plus beta. Therefore, f is equal to mg sine theta divided by 1 plus 1 by beta. Here, don't get confused, it is 1 by beta. Because in the numerator it is beta, right? Let us write in the denominator so that you will get 1 plus beta divided by beta. So 1 by beta plus beta by beta is 1. So therefore you will get 1 plus 1 by beta. This is frictional force acting on it. Keep that formula in your mind. Here the formula for that is, frictional force formula is what? What is a formula for frictional force here? mg sine theta divided by 1 plus 1 plus 1 by beta. Mg sine theta divided by 1 plus 1 by beta. This is frictional force. Now let us discuss about next. What about velocity? What about kinetic energy and everything? If we want to discuss about velocity, here it is quite simple to understand. Now the object is rolling down with an acceleration of g sine theta by 1 plus beta. If we want to find the velocity at any time, then we can apply equations of motion. V is equal to u plus at, s is equal to ut plus of at square, means how much distance it is traveling, within what time it is coming. Then we can write v is equal to u plus at, s is equal to ut plus of at square. Like that we can apply equations of motion, because in A all the values are constant. If you can observe, g value is constant, sine theta is constant, because angle of inclination doesn't change. 1 plus beta is also constant. Yes or no? K square by r square, it is constant for a particular object. That's why acceleration is entirely uniform for a particular object. Okay. Now let us suppose, let us do one simple problem. A solid sphere of radius r is equal to 20 centimeter is rolling down the inclined plane, of angle 30 degrees. Okay, of angle 30 degrees. Now find the length of the inclination, we will discuss that also. Length of the inclination, L is equal to, consider it is for example 40 centimeters, anything else like 100 centimeters, no problem. 1 meter, length is 1 meter. Now find the velocity of the object when it reaches bottom of inclined plane. When it reaches the bottom of inclined plane. Okay, if we want to find this, then usually the formula is like this. What is the formula? Formula is A is equal to, solution I am writing, A is equal to g sine theta divided by 1 plus beta. Here for solid sphere, what is beta value? just 2 by 5. How can you say? Because k square is 2 by 5 r square. K square is equal to 2 by 5 r square divided by r square. R square gets cancelled. You will get 2 by 5. Okay. Now let us substitute that value here. Therefore, acceleration is equal to g sine theta. What is g value? 10. Consider it is 10 into sine 30 value. It is 1 by 2 divided by 1 plus 2 by 5. 1 plus 2 by 5 means what? It is 5. 10 into 1 by 2 means what? 5 into 5 divided by 7 means what? 25 by 7 meter per second square. Now it is having a uniform acceleration because acceleration we got it as constant, right? So now if you want to find the velocity when it reaches the ground, therefore v is equal to, we can say that it is u plus at, just applying equations of motion. Now v is equal to u plus at. No, we don't know the time taken, right? Do we know the time taken? No. So first let us discuss the another formula. Like distance is given now, length of inclination is given, yes or no? Here length of inclination is given, L is equal to 1 meter, right? Now L is equal to, S is equal to ut plus of at square. L is equal to, L is equal to ut plus half a t square. What is L here? L only 1 meter. Okay, which is equal to u value 0 plus half into a value g sine beta, or sorry, g sine theta by 1 plus beta into t square. Sorry, what are we finding here? I'm sorry, time we are finding out, right? Okay, let us find the time, no problem. So L is equal to 1 meter. 1 meter is equal to half into g sine theta. What is g sine theta? That is 10 into 1 by 2. That is 5. 5 by 1 plus 2 by 5. 25 by 7 we have got is 25 by 7. 25 by 7 into t square means 25 by 14. Therefore, t square is equal to 14 by 25. And hence what is time taken here? Root of 14 by 25, which is equal to, let us keep it like this only, no problem. That is root 14 by 5 seconds. Root 14 by 5 seconds. We have got it. If you want to find the velocity, quite simple. V square minus u square is equal to 2as. I need not apply the t value again because I've got a different value. So it is better to apply v square minus u square is equal to 2as, right? So v square minus u square is equal to 2a into s is L. We need to find out v square value. U value 0, which is equal to 2 into 25 by 7 into L value 1 means 50 by 7. Therefore v is equal to what? Root of 50 by 7 meter per second. This is how we have to calculate the velocity. Okay. Now let us discuss some questions. Let us have a discussion about some questions which are very interesting questions regarding inclined plane. Let us see those questions. They are very interesting questions. Now see, these are the questions. First one, in first case, okay, let us see the first case. There are two spheres, solid spheres, both are solid spheres in the first case. Both are solid spheres, but in the first solid sphere, but both are of different masses and different radius. Both are of different masses and different radius. Okay. Now if both of them are assumed to be rolling down the inclined plane, both the spheres are assumed to be rolling down the inclined plane. Inclined plane means inclined plane of same angle. Here theta and there also theta only. Okay, an angle of inclination does not change, but mass of the object changes as well as the radius of the object changes, but both are solid spheres only. Now while they are rolling down, which one reaches the ground first? Very interesting question, right? Which one reaches the ground first in the first question? In this question, which reaches the ground first? It is very simple. as you may have assumed that the solid sphere of heavier mass may come down first or whatever it may be like. But the answer for this is both reach the ground simultaneously at the same time. How can you say that both reach the ground at the same time? See, it is quite simple. If we find the acceleration, what is acceleration formula? G sine theta by 1 plus beta. Beta is same for both of them, irrespective of whether it is having a great radius or lesser radius, greater mass or lesser mass, whatever it may be. Irrespective of it, even it is a smaller sphere, even it is a bigger sphere, beta value is how much? 2 by 5 only. So it does not change. G value does not change. Angle of inclination does not change. So acceleration for both of them is same. If the acceleration is same, if the length of the inclination is same, if the angle of inclination is same, then time taken is also same. That's why smaller sphere, bigger sphere, both of them are dropped from an inclined plane. Then we can say that both reach the ground at the same time. Now let us see the second question. In both the spheres, see the second question here. In both the spheres, one is solid sphere and the other one is hollow sphere. But both are of same mass and same radius. Both are of same mass and same radius. Which takes more time to slide down? Which takes more time to slide down? More time to slide down. I'm sorry, not sliding. I'm very sorry. Not sliding, roll down. Now, as you can easily guess that solid sphere and hollow sphere both having different beta value, right? For solid sphere it is 2 by 5 and for hollow sphere it is 2 by 3. So both are having different values and hence you can easily say that both do not have same accelerations. Yes or no? But which one will have greater acceleration? Easily you can say that it is solid sphere. How can you say that A is equal to G sine theta by 1 plus beta? What is 1 plus beta? 1 plus beta is what? 1 plus G sine theta by 1 plus 2 by 5 means what? 5 by 7 into G sine theta for solid sphere. And for hollow sphere it is just 2 by 3 means what? 3 by 5 G sine theta. Then which acceleration is greater? You can easily say by using this. 5 by 7 means what? It is approximately like 0.7. Yes or no? Means 7 sevens or 49. So 0.49 means approximately you will get 5. Okay, so 0.7 for the first one for solid sphere, but for hollow sphere it is 0.6 only. Means for hollow sphere the acceleration is lesser. If the acceleration is less, then the time taken will be more. It takes more time to reach the bottom of the inclination. It takes more time. It takes more time. It takes less time. Solid sphere takes less time, hollow sphere takes more time. Very interesting, right? Now, next, the third one. There are 4 types of objects. Like first one is solid sphere, hollow sphere, third one is disk, and the fourth one is ring. In which case, okay, suppose in case of pure rolling, in this I am going to ask again 2 questions. In case of pure rolling, which one reaches the ground first? If all these 4 are pure rolling, okay, now rolling purely, if all of them are rolling, okay, without sliding, then which one reaches the ground first? We can easily say that solid sphere, because for solid sphere Okay, now as we have just assumed that for solid sphere acceleration for all of them, let us write first solid sphere. What is the acceleration? Just now we have got for solid sphere 5 by 7 g sin theta, 5 by 7 g sin theta. And for hollow sphere it is how much? 3 by 5 g sin theta. And for ring or for disc it is how much? For a disc it is g sin theta by 1 plus beta means what? 1 plus 1 by 2 means 2 by 3 g sin theta. And for ring it is okay, g sin theta by 1 plus 1. For ring beta values 1, am I right? K square by r square value. So therefore you will get for ring it is g sin theta divided by 2. Now let us write these values approximations. 0.7 g sin theta, it is 0.6 g sin theta, it is 0.6 only, right? 0.66 here, 0.66 g sin theta, and here 0.5 g sin theta. Now among all these, which one has more acceleration? You can easily say that it is solid sphere. So that solid sphere comes ground first. Solid sphere rolls fast because acceleration of it is greater, time taken will be lesser. Okay, now for which one acceleration is very less? It is for ring. After that for hollow sphere. After that for disc. After that for solid sphere. Which one takes more time to come down? That is for ring. That is in case of pure rolling. Now let us discuss about second condition. In the absence of friction, which one reaches the ground first? Easily we can say, if there is no friction, all the objects do not roll, they just slide. When they just slide, acceleration of either solid sphere or hollow sphere or disc or ring or whatever the object may be, its acceleration will be g sin theta only, because it is not rolling, there is no friction. That's why all are having same accelerations. That's why all of them will come down at the same time. Understand? So this is the topic rolling on inclined plane for today, and tomorrow, means in the next class, I'll discuss some problems regarding rolling on inclined plane, or else let us start doing rotational collisions. I'll explain rotational collisions also in the next video. So keep watching my videos and gain conceptual knowledge and gain the knowledge to solve the problems very easily. Okay, for that just keep on watching my videos and please like, share and subscribe to my channel. Thank you.